For low-speed signals, oscilloscopes typically use a high impedance input to make measurements. This follows the concept of impedance bridging, where the load, in this case the scope, is much higher impedance than the source, the device under test. This helps to maximize the voltage at the scope while limiting the current. This maximizes signal integrity for the measurements. As we said, this works great for low-speed signals. As waveforms get faster, capacitance or inductance in the device under test adds some reactance into the system, which creates reflections in the signal. To reduce reflections, the load impedance, source impedance, and characteristic impedance of the cabling should all be the same. By convention, electronic engineers use 50 ohm impedance for most applications today. 75 ohm is also used for some cable applications. Other values are also possible, but 50 ohms is commonly used with oscilloscopes and spectrum analyzers. Higher speed scopes have 50 ohm termination inside, and external adapters are also available. For further information on why impedance matching works in this way, you can refer to a number of online tutorials, or start with the impedance matching entry on Wikipedia. To show the effect of these reflections, let's look at a simple 10 MHz square wave. Here we're looking at it in high impedance mode. We can see the signal has significant defects. This is due to the reflections. We can save that as a reference. Now, let's go into channel 1 and switch our scope input to 50 ohm mode. We can now see a much squarer looking pulse that is much closer to the actual signal. When debugging high-speed signals, make sure to understand the impedances being used in the system to maximize signal fidelity.